Shapes by Philip Ball, a book review by Mohammed Sheikh. Philip Ball is a freelance science writer and author of several science books that have links to art and architecture. Using Darcy Thompson's work on growth and form as a starting point, Shapes by Ball shows the intricacy and morphology within shapes and patterns found in nature and person-made entities, while providing an understanding of these linking science, art, and design. Being part of Nature's Patterns trilogy, Shapes, Flow, and Branches, Shapes is assessed as the starting point of this journey of natural patterns. This initial chapter acts as an introduction, but doesn't define what the book will go through, however gives the reader knowledge of why shapes and patterns are symbolic. He achieves this by divulging how man-made patterns are difficult to produce, whereas natural methods, form finding and pattern finding, seem easy, possibly due to the mathematics and set of rules that determine these instances. However, not all natural patterns are easy to spot and are extracted by in-depth research. The chapter heavily relates to Darcy Thompson's work and its comparison to Paley's manuscripts. I struggled to initially understand these aspects as I didn't know the works of either individual, therefore would be beneficial to have this light knowledge before reading. The beehive has been a prominent part of biomimicry for its structural purposes and efficient organisation. Though Ball explains how honeycomb structures are not only found within beehives, within the work of Ernst Haeckel, honeycomb-like structures can be seen within marine life, specifically Alonia hexagona. I say honeycomb-like structures as though the majority of the mesh is made of hexagons. There are pentagons within parts of the structure that forces a flat surface to become curved. I found this closely related to Voronoi fractals and further thought if this would be apparent within different sided polygons. Not only does this chapter cover beehive structures, but also the form and structures of bubbles. Again, relating to the beehive, bubbles stack within a hexagon-like pattern. However, bubbles can merge, creating a stable structure between the midpoints of the nodes, while also showing the majority of structural angles of 120 degrees in flat surfaces and 109.5 degrees in tetrahedral gatherings. Ball also divulges within the works of Frei Otto how his research of bubble forms defines his projects. This also assists in using the least amount of material within a structure to make it more sustainable. My initial thoughts in coming into this chapter were that Ball would discuss the physicality of waves. Though he does talk about this, he mainly looks at how the results of research create wave-like patterns. Ball initiates this chapter about the laws of thermodynamics and goes into the anomaly of the second law, with that anomaly being the Bezier principle on how a reaction between bromate and malonic acid produces an autocatalytic pattern which goes against the second law of thermodynamics. Developing from this, he talks about predator-prey relationship between rabbits and foxes, and how this closely relates to the before-mentioned Bezier reaction. It was stated that where there was grass, there are rabbits. When there are more rabbits, the population of foxes increases due to the larger food source. However, as the rabbit population diminishes, the foxes have little to eat and die off, allowing the rabbit population to grow again. Ball puts this principle as an L system, a pattern that follows a set of rules. However, linking back to the Bezier reaction, a similar pattern can be produced mathematically, which therefore proves that the patterns are universal, not just determined by chemical reactions. Within the animal kingdom, there are several examples of naturally occurring patterns on the fur, though these patterns come under spots or stripes. This chapter divulges into the development of how the patterns occur and how to relate to Alan Turing's work of Turing lines. It's discussed that Turing was ahead of his time, as these patterns relate to Kipling's question, how do animals get their stripes? The phenomena between spots and stripes within animal pelts is iconic. Spots are created by dissipation as the subject grows. This can be seen in jaguars as the cubs have dense dark spots, and as they age, the spots dissipate, producing the traditional jaguar pattern we are familiar to. Striped animals such as zebras have a set amount of stripes determined by within the embryotic stage, as common zebras who develop stripes within the earlier stages of the embryotic stage have less stripes compared to the less common zebra who develops their stripes later in. This is because there will generally be more space for stripes along the spine when the embryo is larger. All life has a cycle, starting from birth and cycling to death in a coherent rhythm. From the introduction of the BZ reactions relationship with the predator-prey models from Chapter 3, discussing most predator-prey relationships are autocatalytic. This relationship is enhanced by an obstructed environment, allowing for both to coexist for longer. This creates more noise within the results and produces a more chaotic environment and outcome, with researchers saying that they would choose chaotic patterns over uniform spirals as the chaos resembles a more in-life perception. As mentioned, Turing's patterns are seen within animals but can also resemble a predator-prey-like reaction within vegetation, specifically grass in arid conditions, where only the healthiest roots get sufficient nutrition, resulting in a pelt-like pattern. I found a lot of this chapter to resemble previous chapters. However, reading through this gave me a more in-depth knowledge of the previously mentioned subjects in the book. Vegetation has always been an inspiration for shapes and patterns through biomimicry and biophilia. Ball goes into the mathematical principles within plants. The first observation made relates to the growth of stem plants and how the leaves radially grow at specific angles to provide the maximum amount of sunlight. From this example, Ball provides an example of biomimicry with application towards solar gain within a structure. The Fibonacci sequence, or the golden ratio, is a regular occurrence within pattern formation, as Ball denotes that it can be seen within the formation and organization of the seeding and leaf positioning of plants, with each leaf rotating 137.5 degrees around an axis. It proves the perfect organizational system. However, if the angle changes even by a tenth of a degree, the pattern cannot become as efficient. From this, it gives evidence that computational methods would be needed to replicate this. Later in the chapter, Ball discusses how fruit grown proves evidence to Turing's patterns having spots or stripes depending on how many nodes they have. Though this is the first practical aspects I have seen with Turing lines, and this helps with the structure and form of the fruit and can relate to architectural principles. Ball starts this chapter by discussing the assumptions of Haeckel's research into embryos, stating that embryos take forms of past ancestral forms of Homo sapiens as they develop. However, these results were dramatized and had a bad effect on the rest of Haeckel's research. I like how Ball doesn't just praise relevant researchers but also shows them in full transparency. Other than this, the main subject Ball talks about within this chapter is how fruit fly embryos exhibit Turing patterns. A regular pattern within this book is, rather than diagnosing from Darcy Thompson's work, he attempts to prove Turing's theories within nature. Ball ends this chapter by observing how adaptation and evolution have affected our appearance since the creation of life on Earth, with the question of how we will adapt and evolve further. Ball provides a clear and in-depth understanding of shape and pattern formation, which provides mathematical understanding to link to biomimicry and computational architecture. However, to fully understand this book, you would have to read all the material, as though the first half of the book describes the basic principles and the second half provides more evidence and acts as a pre-appendix. I thoroughly enjoyed reading this book and look forward to reading the next books in this series.